let me begin by thanking the traditional owners of the land on which we stand, which is the Yaggara and Turrbal people, but also the traditional owners of the entire Great Barrier Reef catchment. And there are many groups. We need to remember they were our first scientists. They have been here for tens of thousands of years, studying ecosystems, managing ecosystems, and working out how to maintain them in a sustainable fashion. Something that possibly, that with the arrival of Europeans, my ancestors, 5 or 6 generations ago, has not gone particularly so well. Let me recognise Troy, Dean of Science, Tony, Head of Maths and other stuff. Kerry, nobody ever called me a distinguished professor of anything. That's not old enough. So I aspire to be called a distinguished scientist. But let me also acknowledge all the citizen scientists who are here in the room, also online. And as Angela pointed out, I am an avid citizen scientist. Let me begin possibly by saying something about science that is the least popular thing I'm going to say all night, and that is, I don't really love science. I don't really love maths. People say I'm a mathematician, maybe, just. People say I'm a scientist. After 200 PhD students and postdocs and honours students and 680 peer-reviewed papers could mean I'm a scientist. I don't love it. I actually love nature. I love nature, and I see science and mathematics as a tool to help nature. That's it. It is a tool, and it is the most and ridiculously powerful tool to help nature. And let me begin really just by telling you a long story about why I care about the Great Barrier Reef and why I got involved. And I'm going to start with another terrible story about the Great Barrier Reef. So 1998, they came to myself and another man called Bob Pressey and said, we're going to do all the rezoning of the Great Barrier Reef. And in 1998, the Great Barrier Reef was only 4.7% protected. So most of the world and even most Australians thought this is the biggest marine park in the planet. It's the size of Italy, as Angela has said. It's the size of Italy. So it's completely protected. Rubbish. It was protected from mining. 95% was fished, trawled and fished. Only 4.7% was protected. So it was probably one of the best marketing and con jobs the Australians have ever done. At that point, we had a senator, Robert Hill, who wanted to increase marine protection around Australia. And the Great Barrier Reef Marine Park Authority came to Bob Pressey and I said, we really need to rezone the Great Barrier Reef because only conserving 5% of it from fishing is not enough. I mean, that's ridiculous. This is a bit like saying Australia has a national park system where you can shoot and kill any kangaroos, wallabies, wombats and koalas you like. And we don't care. We'll only protect 5% of that. You can pick flowers, you can take wood. So here was a park system that looked like a wonderful park system, but only 5% was fully protected. So we went for this rezoning. It was driven by the Howard government. It was driven by Robert Hill. And the scientists came to us and said, we have all this data. How do we decide what to protect? So the Great Barrier Reef is roughly, I mean, we call it the Great Barrier Reef. We call it one big World Heritage Area. That's a little bit of a lie as well. It's 5,500 reefs, 5,500 separate reefs all make up the Great Barrier Reef. And then you've got to decide what is a reef and what isn't a reef. And the question then was, if we can protect, say, 30%, which is what we aim to protect, if we're going to protect 30% of those 5,500 reefs, then which ones do we protect? And that's what we built our software to do. We built mathematical software, it uses interlinear programming, a problem, it uses simulated annealing as an algorithm to pick which of those 5,500 reefs would be best to protect to achieve the outcome of conserving nature, improving fisheries, and minimising the impact of all the other users of the reef. which is tourism and transport and other things. And we took that problem, which is a verbal problem, which is something about what the community wanted, and we turned it into some mathematics, and then we wrote an algorithm to solve that mathematical problem. You think, well, that can't be that hard. But let's quickly think about that problem. 5,500 reefs. Every one of them could be protected or not. How many solutions to that problem are there? 5,500 reefs, and each one could be green or not green. The number of solutions to that problem is 2 to the power 5,500. 2 to the power 5,500. And that's roughly 10 to the 2,000. And the physicists in the world, 10 to the 2,000, is that a big number? The physicists in the world tell me that the number of protons in the entire universe is 10 to the power 80. So we had a problem where the number of potential solutions was so much bigger than the number of protons in the universe. It was inconceivable. So fortunately, although I'm a rubbish mathematician, I knew some mathematicians who knew how to do good stuff, and we stole their things, stole their algorithms and wrote some software. We got the Great Barrier Reef rezoned, and that software now has built most of the protected area systems in the planet. Changed 20% of the surface of the planet. Half a PhD student that I supervised of those 200, which is nice, and I never made a cent. But to the point of citizen science, where did all the data come from? Because if you're going to protect the Great Barrier Reef, first thing is you want to do it in a way that doesn't really annoy people who fish a lot, the recreational fishers, the commercial fishers. The second thing you want to do is build it in a way that you actually conserve the diversity of life. And Angela's already pointed out the Great Barrier Reef has enormous diversity, hundreds of fish species, hundreds of coral species. Where are they all? Well, we can't pay professional ecologists and taxonomists to see every single part of the reef. So there's three things that I think are very exciting about citizen science. One is, as those people who've been involved in classifying the reef, is you can observe images, identify species, classify habitat types, algae, non-algae, coral, sand, gravel. And those are fundamental inputs to the basic maths that created the Great Barrier Reef rezoning. They are fundamental inputs to the basic maths that created the Great Barrier Reef rezoning. Because it's really, really expensive sending professional CSIRO scientists snorkeling around an area the size of Italy. So if you can do it with cameras and drones and machines and then get citizen scientists to classify those things, that's an enormous benefit. In fact, it would be impossible without citizen science. And I'll just say two more things about citizen science before I throw the microphone to Kerry or back to Angela. So what this project has been all about is what is where. So I think that's the most an interesting part of citizen science. What is where? As a bird watcher, that was my obsession. What species is where? The second thing is, after a while, you start to ask the question, is anything changing? So I think the next step is, let's go back to the same transects, the same places, the same videos in 19, 20, 21, 2022, 2023, 2024 and see, is the coral cover increasing? Is it decreasing? Is the number of parrotfish going up or down? So change is the next thing, because then you start to understand what's happening. That I consider the second phase of citizen science. The third phase of citizen science is anything we do help at all? Is anything we do matter? So if we put something in a protected area, does it work? I think the general public thinks it does. There's an enormous amount of data that suggests it often doesn't. It is amazing, for those of you who have been looking at these reefs, the amount of information that tells us whether or not a protected area works or does nothing is almost non-existent. So looking at sites in and out of protected areas and seeing whether protected areas actually deliver increases in coral cover, whether protected areas deliver increases in the abundance of fish, is an incredibly important activity. It seems so simple, but we have very, very little data about those issues. So that's the ultimate part of science. And our view is that more people we can support to get engaged in citizen science, the more they start asking critical questions about, does the management of the Great Barrier Reef, is it delivering outcomes? Is it generating what we want, which is the diversity of fish, which is the abundance of fish? Is it generating ecosystem services like carbon sequestration? Until we can actually measure that, we don't know whether any of our actions work. And that's the exciting thing, I think, and why the Office of the Queensland Chief Scientist like supporting citizen science in many, many projects all over the state, is because it's leading the entire community to ask questions about how can we save nature, how do we save ecosystem services, and how can we deliver outcomes that are useful and make them scientifically credible as well. So thank you very much.